All right, we got our board routed. We have a few more steps to do. Let's see, I'll go ahead and move this down here. I want to show you a few more things you can do that can make your board a little more robust. I'm going to select the bottom layer here, and I'm going to tell it place Polygon Pore. And what that means is a polygon is a shape, and I'm going to pour it full of copper. So you see a lot of vacant space on here. I'm going to tell it place a polygon pore, and before I place it, I hit tab to get my properties. And what net do I want to connect it to? Well, I want to connect this to ground, because I want to have a nice ground shield on the bottom of my board there. Then I have an option. Do I want the copper to be solid or hatched? I want it to be hatched. So I tell it OK. Now I'm going to come here and I'm going to draw a box around my entire board. Just like this. Right click when I'm done drawing. Right click again, and look at this. I have filled that full of copper strips. Looks cool. Now let's go to the top layer and we'll do the same thing. Place Polygon Pore, and maybe just to be different, what I'm going to do this time, I'm going to hit tab and I'm going to tell it I want it to be the plus 12 volts. That looks good. So I'll come here and I'll draw this box again on the top layer. There we go. And I have copper on the top. You see the copper on the top is red, copper on the bottom is blue. Now those straight lines are nice, but let's see what else we can do. I'm going to highlight that, hit tab again for properties. Oops, I lost it there. I got the wrong one. Properties. I'm going to tell it 45 degree. Let's look at that one. Hit here. I'm going to go back to Tools, Polygon Pores, and repore all my polygons. Look at that, a nice hatch. That looks even better than the straight lines. So let's do that with the bottom one too. Properties, 45 degree, Tools, Polygon Pores, repore all. Alright, so now I have this nice cross-hatched polygon. That looks great. If I want to work on my board, it's hard. You see, it's hard to see the traces on the bottom. I can come up here to Tools and Polygon Pores and tell them put my polygons on a shelf. Basically, get them out of the way so I can see through them. Now that they're shelved and they're out of the way, I can see well. Let's do something else. Maybe I want to come up here and here's one of my functions. I can place a via. So let me just hit the tab key, tell it what net I want it to be. I'll make this one, let's see, ground. That's good. And so I have this via, and maybe I want to place it right here. There we go. So now I've placed that via. That's changed a few things now in my board. What happens when I come back up here and tell it Tools, Polygon Pores, Restore? Uh-oh, I got green. Let's see, bottom layer, yep, top layer, problem. What's the problem? Right here. This guy is now touching the copper pore. We don't want that. So what do? Tools, Polygon Pores, repore all of them, and it fixes the problem. So it's a handy function to have to hide your polygon pores, get them out of the way. You can make some changes, come back and repore them. Let's look and see what happens when I did that. Now you remember on the bottom layer, I made this net ground. So what happens to the pins that go to ground? Let's take a look. Look at this. This ground pin is connected right here through these spokes. And notice the 12-volt line not connected through those spokes. It doesn't go to ground. Same over here. I have a ground on this cap and a ground on this cap, but the minus 12 doesn't connect. Let's look at the top layer. Top layer, I have plus 12 volts connected through the spokes. Same here, plus 12 volts going to the spokes. So I'm connecting on my net, same with my IC here, through the spokes. But I'm not connecting with the rest of these guys. Now, why do they use spokes? They use spokes for a specific reason. When you go to solder this guy, copper is a very good thermal conductor. So when you go to solder these, if I had this totally poured solid with copper, all the heat would transfer out through that copper, and it'd be really hard to get this hot enough to solder. I'd have to heat the junction for a long time. But with these little spokes, I don't let the heat transfer out too fast, and I'm able to solder this. That's the reason why they use spokes and not just solidly connected. Alright, look at that. We have a nice board. So I'm going to come to File, Save All, and we need to generate files that can actually build these boards. And how do you do that? Well, let's take a look. We can go to File and Fabrication Outputs. That's the important one right there. On Fabrication Outputs, we're going to use two different outputs. The first one's going to be Gerber Files. I'm going to select that. And here you'll see under General, what are we using? We're using inches right now. The format is 2 by 5. It's just telling me that I have 2 leading digits from the decimal point and 5 trailing digits. Which layers do I want to use? Oh boy, I got to figure out which layers. Or I come down here to plot layers and say, hey, whatever layer I'm using, turn it on. And it turns them on for me. Top overlay, that's the silk screen, the yellow layer. Top paste, it's a solder paste where it keeps the pullback from the solder mask on the top. Here's the top solder, the top layer, right? These are all the layers we're using. Mechanical layers, that's kind of defining the board. Keep out is the edges of the board. So we're going to generate all these. I'm going to tell it OK. Now it's going to go to work, and it generates a CAM file right here. I'll go back to my PCB. You'll notice the CAM file has all the copper but no holes. So I go back to my PCB. I'm going to tell it File, Fabrication Outputs, NC drill files. We want the NC drill files. That's going to define the size of the hole and where it goes. I'm going to click on that. I want to make sure I use the same units in the same format. If I had used inches and 2 by 4 on my Gerbers, I need to use inches and 2 by 4 for my drills. So I'll tell it OK. Import the drill data, OK. There's all the holes. Now I'll come up to my file, save all. Yes, you can save that. And yes, you can save that one. Alright. So I don't need the Camtastic documents. I'll close them. Now I've generated my files. Those are the files we need to generate the board. And what do they look like? Well, let's just see. If I open Explorer, and we'll go to where I have saved them on my machine here. We're down here to Protel Designs, and then we go down to the op amp. Alright, and you'll see I have under my op amp, there's one that says Project Outputs for op amp. If I open that folder, there's the files I just generated. Now here you'll see it says op amp and GBL. Well, that stands for Gerber Bottom Layer, Gerber Bottom Solder Mask, Gerber Keep Out. Right? They're all telling me what they actually do. And there's no magic on these files if you look at them. For instance, the Gerber Bottom Layer, if I told it to open it up and let me see what it looks like, you'll see it's all text. Let's open it and see. It opened it with let's close that. It opened it with Altium. Let's go back here. We can open it with a different program. Copy Smart Link Sharing. Open with. I'm going to open it with Notepad because it's just a text file. And here it is. This is my Gerber bottom layer. And what this is doing, it's kind of like G-code on a CNC machine. It's telling this equipment how wide the trace is, where it starts, where it goes, what angle it goes off on the next one, how it moves. So this is kind of like the CNC of moving this trace around to generate all the bottom layer. It'll be the same with the NC drill files, which is not the DRR file. It's this one that says text. If I open the text file, same thing, op-amp text. This is the drill formats. It's going to tell you where it goes. There's the X's and the Y's, and it's going to tell you which tool to use. So they're just text files, but these are the files we need in order to generate a PCB. Generally what we do is we'll select them all. I can right click, tell it to send to a compressed folder. So it takes all those and zips them. This is what we'll send to the manufacturer, or what you'll send to the TAs when we want to get our boards manufactured. Alright, that should do it for this video. Stay tuned for the next one.